So on the next one, I see y is equal to -2 tangent of 3x minus pi plus 1. Alright, so the first thing I'm going to do is, again, I'm going to look at this and I'm going to rewrite it. So I'm going to write this as y is equal to -2 times tangent of 3 times the quantity of x, now minus pi over 3, close that parentheses, plus 1. Alright, so again, I do that just to make our lives a little bit easier. It'll help us out with the period here in a minute to make that a little bit nicer, and it makes us able to see that shift a little bit more clearly. So, again, my transformations are going to be right pi thirds, a horizontal shrink of 3, multiply your y's by -2, otherwise known as the negative is going to reflect over the x-axis. This time, and then that 2 out in front actually makes that a vertical stretch. And then finally, the last thing that we're going to do is we're going to shift the entire graph up 1. Alright, so remembering tangents, that weirdo. So the first thing that I probably want to take a look at is normally my period of tangent is pi. Unlike sine and cosine, who have that 2 pi. So if we're going to change our period, it's going to be pi divided by b instead of 2 pi divided by b like our last example. So this time my b is 3. So my period this time is going to be pi thirds. So pretty handy dandy that I can break up my graph into thirds and sixths, which might be helpful here in a second. I don't know why my page keeps moving, but let me adjust that again. Alright, now that this is readjusted, remember that my period is now pi over 3. Also remember that tangent is before and after that y-axis. So my asymptotes from tangent are actually going to be at pi 6 and negative pi 6. I know I just said those out of order, but I'm marking both of them. So that way my entire period is 2 pi 6, otherwise known as pi over 3. So most of the time my tangent function would be like here, and then it'd be halfway in between to pi fourths type of deal, and it would look something like that. Remembering itty bitty tangent function looks, but we have shifts and everything else going on, so don't get too used to that quite yet. Alright, so now we actually have to, shift and stretch and shrink and all that. I know it's time I talk about shift sandwiches, but honestly, these are the only functions where that shrink is probably or stretch is easiest to do the first. Alright, so shifting this right pi thirds is actually just going to shift both of my asymptotes right 2 boxes. Alright, so there's my asymptotes. So now if I was to draw my graph, it'd be like here, here, and here. Halfway in between with my 45s. But I'm not quite done yet. I still need to reflect over the x-axis, which is actually going to put my other points down here, here, and reflecting those over the x-axis. And then I need to vertically stretch those by 2. So instead of it being at 1s, they're actually going to be at 2s. Alright. And then the last thing I need to do is shift everything up 1. So all of my points, the whole whopping 3 points that we have to deal with, since asymptotes aren't affected by shifting up and down or vertical stretches or shrinks. So shifting all of my points finally up 1, my graph should look something like this. So yes, my tangent graph can end up looking like a cotangent, and vice versa. These graphs are fun. Just like sines, if you do the right period shifts and phase shifts and all that kind of good stuff, sine can end up looking like cosine as well.